start with the third module for today, that is performing data engineering with Azure Synapse Apache Spark pools. So here in this lesson, you will be learning about analyzing data with Apache Spark in Azure Synapse Analytics, transforming the data with Apache Spark in Azure Synapse Analytics, and using the Delta Lake in Azure Synapse Analytics. So let's start with the first lesson, that is analyzing data with Apache Spark in Azure Synapse Analytics. So before going with that, let's understand what is Apache Spark. So you might be using, many of you are already aware with this Spark on other platform like Azure HD Insights or Azure Databricks. So the Spark implementation in Azure Synapse Analytics is actually based on the same open source Apache Spark platform that is hosted as a pool. That is what we call it as a cluster of a driver and the worker nodes in the Synapse Analytics workspace. So those who are not familiar with this Spark, the core concepts is to understand the distribution of data processing across multiple worker nodes, and the workers each work on their subset of overall processing task in parallel. They will be enabling massive scalability across huge volumes of data. So here the Spark pool will be configured to use a specific Spark runtime. So this is very much essential, as a version for a particular package or Spark and related technologies installed in the pool, they have to be mapped properly. So in many cases, you need to choose an appropriate Spark runtime for the specific version of this Spark, Python, or the other packages that you are processing. And that depends on the workloads that you are actually working with. So whenever you use the Spark pools in Azure Synapse Analytics, they will be the named serverless cluster that have the capability to auto start and stop whenever it has been idle, and also it has the capability to auto scale also. So this is the specific Spark runtime version is also very much required here. Okay, and this Spark will also support you with multiple languages, and you can also go with this Spark context, and they will be having a good coordination between the multiple executors of worker nodes. Okay, so now let's go ahead. Use Spark in Azure Synapse Analytics. So whenever you use Spark in Azure Synapse Analytics, so that is the primary way that data engineers and data analysts and data scientists work with Spark, by using the notebooks. They contain a mix of code and notes in the Markdown. And this Azure Synapse Studio will include the native support for notebooks based on the interactive Python notebook, that is IPNYB format, that is actually popularized in the tools such as Jupyter. So despite the name of the format, Spark notebooks can include code that has been written in multiple languages, including Scala and SQL, as well as a Python. So when using Spark in Azure Synapse Analytics, you can work with data in multiple stores. Most commonly, you will process data files in a data lake. Typically, the default data lake for the workspace, which is hosted in Azure Data Lake Storage Gen 2. You can also use various link services or connectors to work with the other data in other sources also. That is also possible. So this is how you can use Spark in Azure Synapse Analytics using the integrated notebooks. And if you want to analyze data with this Spark, you can use this magic command, that is this percentage is termed as the magic at the beginning of the code. This will instruct the Spark to treat the following code as a Python, and you could also use percentage Spark to indicate that the code still contains the Scala code also. So the data frames are not the only way to work with the data in Spark, but they are also the most common one. And other data object types, including resilient distributed data set, which are the core native building block for the data structure in Spark, and data sets, which are also very much essentially strongly typed data frames, we can say. And these data frames are actually provided on Spark via the Spark SQL library, and they are also functionally very similar to Pandas data frames as well, that are actually commonly used in Python. So the code sample here, which is on the slide, they are actually showing how to load a data frame with data from a CSV file. You can also load the data from other formats also, including the Parquet file. And you can also know how to use some of its built-in methods. So specifically select and group by, and also the functions to manipulate the data. So for details about more of these things, you can refer to multiple documentations available on Microsoft website for most of your learning, we can say. And you can also use analyzing data with Spark using the SQL expression also. So if you're not good at PySpark or Python languages, if you are a good core functionality of SQL, if you are working with and you are very much familiar with the SQL syntax, you can use the spark.sql method to return a data frame, or in a standalone SQL code is also possible. So here you need to be aware of the existence of Spark Metastore, which you can think of as a being as a relational database layer. Okay, in the tables and views are actually defined. So the data itself is stored in files which the tables overlay, and the Spark Metastore are based on the technology called Hive, so which provides relational data services to open source system such as Hadoop and Spark. So we will be exploring these tables in the Metastore later in this module. And you can also do the visualization with this Spark, that is also possible, so that you can use the notebooks to include the charting capability. So they are actually designed to support the ad hoc data visualization. So when working interactively in the notebook, most professional data analysts and scientists prefer the versatility of graphics library like matplot library, seaborn library to create charts and graph for these reports. That is also there. And as a homework for you, you will be working with analyzing data with this Spark. You can go to this link and refer to the instructions, whatever has been provided, and you can work with this lab for your learning. So now let's have a quick knowledge check. So which definition best describes Apache Spark? Yes, that is a distributed platform for parallel data processing using multiple languages. So you need to use Spark to analyze data in a Parquet file. So what should you do? Yes, you are right. Load the Parquet file into a data frame. So you want to write a code in Notebook cells that uses a SQL query to retrieve data from a view in this Spark catalog. So which magic should you use? You are absolutely right. That is Magic SQL. So now we have this next lesson, transforming the data with Apache Spark in Azure Synapse Analytics. So you can modify and save the data frames. So here you have the code that loads the data into CSV format, and that will help you to save the transformed results in the Parquet format. Sometimes that's the only transformation that you actually require. So in this case, the data is modified by adding a new column called year. You are adding the new column called year that is derived from the order date column by using the year function. So you can see the PySpark data frame API references also over the web. So in this way you can modify and save the data frames. That is also possible. So firstly you will be loading the source file into a data frame, and you can do the modification like filtering of the rows, modifying the columns, deriving new columns, dropping the columns. You can do this modification, and you can write this modified data into a required format, we can say. And you can also use the partitioning data files. This method is also there. So this partitioning of data will actually enable the Spark to optimize the query performance by distributing the processing for each partition across worker nodes. Additionally, queries that filter based on the partitioning columns will actually improve the performance by eliminating the unnecessary disk input output. So you need to note that the folder names generated when partitioning a data frame will also include the partitioning column name and value in the column. Okay, so it will be having that column is equal to value format will be provided, so that you can also do this partitioning the data by relevant columns you can do. And you can also distribute this data to improve the performance, and the scalability also can be done. So here you can see the year equals 2021, year equals 2020. Here the data is being partitioned according to the year. And next we have is transforming data with a SQL. So many data engineers are familiar with SQL syntax, and they will find it easier to use when manipulating the relational data structures. So creating a view in the metastore will enable you to write SQL queries that return a transformed data frame, so which you can then write as an external table. So these external tables are relational tables in the metastore. that will basically reference the files in a data lake location that you specify. So you can access the data by querying the table or by reading the files directly from the data lake. So additionally, external tables are also loosely bound to the underlying data files. So whenever you drop the tables, that does not delete the files. So you can use this technique to transform the data, and you can also persist it in the files also, and you can also drop the table. So in case if you are dropping the table, and still you can use the transform data files in the downstream process. That is also possible whenever you do the transformation data with a SQL. So here you need to observe that dropping an external table will not delete the data files. This is very important. And you have one of the homework, that is transforming the data using Spark in Synapse Analytics. So after this session, whenever you have time, you can go to this link and look into the instructions, and you can perform this lab for your learning purpose. So now let's have a quick knowledge check. So which method of the data frame object is used to save a data frame as a file? Yes, you're right. That is write operation. So which method is used to split the data across folders when saving a data frame? Yes, you're right. That is partition by function. So what happens if you drop an external table that is based on the existing files? Yes, you're right. The table is dropped from the metastore, but the files remain unaffected. That's correct. So now let's go for the next lesson, that is using Delta Lake in Azure Synapse Analytics. So you need to understand what is this Delta Lake first. So that is the open source storage layer that will actually add the relational database semantics to your Spark. So note that you don't need to use Delta Lake to manipulate or query the data in Spark using SQL. You can create tables in the Hive metastore with data files in a CSV or the Parquet format, and you can also query them with the select statement. That is also possible. However, the Delta Lake saves the data in Parquet format with additional metastore that enables tracking of transactions and versioning, providing an experience well much more similar to a relational database system in like SQL Server. So most new data lakehouse solutions built on Spark are based on the Delta Lake, enabling you to combine the flexibility of file-based data lake storage with the transactional data integrity capabilities of a relational data warehouse. Okay, this is what we call it as a Delta Lake. And whenever you create a Delta Lake tables, they are just like any other metastore tables, except that the Delta format is used to save the data. So this results in a folder structure that not only contains the data files, but also metadata files that will enable the transactional functionality. So note that to update a Delta Lake table using the API, you actually create a Delta table object based on the path where the data files are actually stored, and use its method to perform data updates, inserts, and deletes. Okay, and the time travel feature of Delta Lake will also take the advantage of metadata, which tracks the transaction in the table. So this enables you to retrieve and compare the different version of the same row based on the sequence of modifications made to the table or given point in time. Okay, and you can also perform this creation of catalog table. See, these catalog tables are how the meta store defines relational tables on top of the file locations. They are not unique to Delta Lake, but you can create managed and external tables for the Parquet and CSV formats too. But increasingly, Delta Lake is the preferred way to build relational semantics into a data lakehouse solution within the Spark. So here you need to know the difference between this managed and internal tables. Basically, these managed tables are stored in the default metastore file system location, and they are tightly bound to the files. So dropping the table deletes the files also, and external tables are based on the files in a specified file system location, and dropping the table does not delete the files. This is the major difference between this managed tables and this external tables, we can say. And next we have is using Delta Lake with streaming data. So Spark streaming is actually a complex subject. So its own right, and we are not going into it in great detail in this course. But the key point is that this Spark structured streaming provides a way to handle a stream of real-time data by using the data frame semantics. So essentially, you can query a stream of data like a boundless data frames that is perpetually receiving new data also. So whenever you are using with the streaming, they will also support you in data lake builds on this by enabling you to treat a table as a source of streaming data for a Spark structured streaming data frame, or as a sink that is called as a target to which a Spark structured streaming data frame writes its data. So this is the sink and this is the source. This is the streaming source, and you can use this delta lake table as a streaming sink like this. Okay, and you can use Delta Lake in a SQL pool also. So until now, we actually focused on working with Delta Lake tables using the Spark. So in Azure Synapse Analytics, you can also work with Delta Lake tables using SQL in a SQL pool. So note that you can use the open rosette function to load the data from a Delta Lake table folder location by specifying the Delta format. So you can also use a native SQL select statement to query the Delta Lake tables in the Spark metastore. So by default, metastore tables are defined in the database name default, but you can create additional databases in the metastore just as you can do it in your SQL server, and you can also do the query of the tables they contain by using the specific database name. That is also possible. Here you're using your default database, and you can also query the Delta Lake using this open rosette function like this. Okay, now we have one exercise of like using a Delta Lake in your Azure Synapse Analytics. So I'll be showing you this demo, and you can just have a look at this demo right. So let me launch my Synapse workspace. So you need to see in this overview page, you need to go for the Synapse workspace, and you need to click on Open Synapse Studio. So click on this Open button. So it will launch your Azure Synapse Studio in your new tab. And now let me switch on to the data page, and we need to verify in the linked tab whether our workspace include a link to our Azure Data Lake Storage Gen 2. So here you could see Azure Data Lake Gen 2 account is there, and you need to see this synapse with your suffix added. This confirms that you have the access to your workspace of Azure Data Lake Storage Gen 2. Now let me see, by expanding you could see this files folder, and verify that inside this files container you need to have a folder named products. If you double click that, you need to have this product.csv file. Okay, so we will be working on this file in this exercise. Now let me select this product.csv. Let me do a right click, and I'll use new notebook option, and I'll select load to data frame. You could see code is being written. To execute this, I need to attach it to a Spark pool which has been created during the deployment process. So you need to just use this drop down and attach to this Spark pool, and you need to ensure that the programming language is PySpark, which has been selected, that is Python. Okay, so you need to review this code, and you can see the files and your data lake account, this suffix, everything is being written. Now the code is being reviewed, so the code is looking proper. Let me execute this first. So for that I'll click on run cell. So now the Spark pool is getting attached, and this will take some time. So let's wait to start. Yes, we have got the results, but we could see that the header information is not available. So to make this first column to be as the header, I need to uncomment this. So let me uncomment and modify this code like this, and let me re-execute this. This time you can see the execution results is faster, and the header is also been added to this results. So you came to know how actually you can use this in the data frame. Now in the next step, let's load the file data into a delta table. Okay, so now what I'll do is, under the results, whatever the results you have got here, let me add one more code section by clicking on this code button, and then let me enter the following code. This code will be available in your activity guide. You can refer to that and you can use the same code here. So now you can see this is the code. I'm just creating a delta table in the path called delta folder, where you could see products delta, and this is the path I'm just providing. And let me execute this code first. Yes, now it has been executed. To check whether this is successfully executed or not, now I'll go to this files tab on the top, and I'll switch back to the root folder like this. So this contains the files container here, and you need to have this folder named delta that should be created, and you need to open this folder, and the products delta table this contains, okay, where you need to find a parquet file. So this is a parquet file. This will be having your data. Okay, now I'll just return back to this notebook 1 again, and I'll be adding one more code cell, and I'll be adding a new code to this code cell again. So again, for this code you can refer to your activity guide, so that you can actually use the same code back to use it here. And this should actually load the object to your delta table, and you need to see all of this updated reflected through your results once we run this. Okay, so I'll just execute this code now. Okay, here I am just creating a delta table object, and I'm updating the table. So after this, you should see that the data should be loaded into the delta table object, and it has to be updated, and you should see this updated reflected here in this query results. So you can see whatever the update you have done, it has been updated in the query results right now. So I'll add one more code cell now and write one more code for the same. See, now this code will actually load the delta table data into a data frame from its location in the delta lake, and it will actually verify that the change you made via delta table object should has to be persisted back again. Okay, that is what it is doing. So let's execute this. Now you could see that the data is being updated accordingly. So the whatever changes is being made, it is being persisted back again. So you could see it from this results. So let's modify this code back again, and here we will be specifying the option that will be used, like the time travel feature of a delta lake, to view a previous version of data. Like we have got the results here. Before this results we had one data, right? So the previous version of data, if you want to see it, you should do some modification here. So let me do some modification for this current code. So let me remove this. So I have just done the modification. So I have included this option version as of, and the 0 I have just provided it here. Okay, now let me execute this code. So when you run the modified code, this result should show you the original version of the data. So you can just compare. This is the previous version of the data. This is the the original version of the data which we had previously. Okay, so here you could see the results. So 3059.991 is there for the list price, but here you can see 3399.999900 is there for the list price. So this is the older version of the data. This was the modified version, we can say. So now let me add another code cell. So here I'll just add a code. So this code basically will tell you the history of the last 20 changes to the table will be shown, and whenever you execute this, there should be two, that is the original creation and the update whatever you made. Both of the versions should be shown here. So you could see the timings, the timestamp, everything is being provided here, and you are getting the two versions of the data. This is the version number 0, this is version number 1. Okay, so version 0 is the previous data and version 1 will be the updated data, we can say. Okay, so this is how you load the file data into a delta table, we can say, and how you could do some transformation or do some modification to the data by using this notebook. Okay, so now we have completed this exercise. In the next part, let's learn how to create a catalog tables. Okay, see, so far you have worked with the delta tables by loading the data from the folder that is containing the parquet files on which the table is based, and you can define a catalog tables that will encapsulate the data and also provide a name table entity that you can reference in SQL code. Okay, basically this Spark will support two kinds of catalog tables for the Delta Lake, we can say. One is it supports the external tables. Basically, you know that are defined by the path to the Parquet files containing the table data, and you have the managed tables that are actually defined in the Hive metastore for the Spark pool, we can say. Now let's create an external table. So to create an external table, just follow the steps. So what I'll do, I'll just scroll down and I'll add a new code cell here again, and I'll write the following code here, and you can observe now the code is written. So you can observe that this code will basically create a new database named AdventureWorks, and then it will create an external table named product external, we can say, and in the database that is actually based on the path to the parquet file what we saw earlier, and then it will display a description of the tables properties, and you need to note the location property, that is the path you specified is matching or is that correct. Okay, now let's execute this code. Okay, now you could see that this has been created, like new database AdventureWorks has been created, and external table name product external has been created, and these are all the column name, and this is the particular data type it has been taken. Now let me add one more code cell, and let me add a one more code for this. So I'm using AdventureWorks database, and let me see the data present in this external table. Okay, so let me execute this. So you should observe that this code is actually using this SQL to switch the context to the AdventureWorks database, so which will return the no data for you. Okay, and then it will query the product external table, which will return you the resultant data set that is containing the products data in the Delta Lake table. So this is the data which has been present in the Delta Lake table, we can say. So this is how you create an external table. In the next step, let's see how to create a managed table. So for that, let me add one more code cell like this, and let me add a code here. Okay, here this code will basically create a managed table name products managed, and this will be based on the data frame that you actually originally loaded from the products.csv file. So that is before you updated the price of the product 771, and you do not specify a path for the parquet file using by the table. So this is actually managed for you in the Hive metastore. You need not have this overhead for you, and you can see that it will also show you the location where actually this has been provided. So if you execute this, the location property will actually show you where actually this was created, and you can see this location is being provided. So files, data lake, dfs, windows.net, synapse, workspaces. Here you can see this has been created. Okay, so this is how this managed table will be handled by this Hive metastore. In the next phase, let me add one more code cell and enter the following code back again. Okay, so again this code will use the SQL to query the product managed table. So let me execute this and query the product managed table now. Yes, now you could see the results of this table which has been there. Now in the next step, let's compare external and managed tables. So to compare that, let me add a new code cell and put on this code. Again, it is using this SQL and it is using the AdventureWorks database. This will basically list the tables. Okay, this shows all the tables which has been present in the AdventureWorks database. Now let me modify the code cell and run it. So here I'm using AdventureWorks. I'm dropping the product external and product manage table. So this code will basically drop the tables from the meta store. So I'm dropping both the tables. So now currently it is showing no data available. Now to check this, I will be returning back to the files tab again, and I'll go to this root folder and I'll go up, go to this delta products delta folder, and here you could see that the data file still exists in this location. This means that dropping the external table has removed the table from the metastore, but it has left the data files intact in this folder. So this is not permanently deleted. Now again, let's view the location of that output what we got. So I'll go to this files back again, and I'll go to this top, I'll go to this files, and let me navigate to this synapse, and let me go to this workspaces, and I'll go to this folder and warehouse folder, and you should note that there is no folder for the product managed table data. So that means that dropping a managed table removes the table from the metastore, and it also deletes the table's data files in this directory. Okay, so this is the difference you can see. Now once you learn this, let's go for the next part, that is how to create a table using SQL. Okay, let me switch back to this notebook window, and let me add a new code cell, and let me write a code for this again. So now just enter this code. So this code will use the AdventureWorks database, and it will create a table called products using this delta, and this is the particular location it has been taken. So now let me click on execute. So currently it is showing no data available. So let me add one more code block and enter the following code, and again I'm using this AdventureWorks, and I'm selecting all the data from the products. Let's see what happens. This time you can see, observe that there is a new catalog table that was actually created for the existing Delta Lake table folder, that is actually reflecting the changes that were actually made previously. Okay, so this is how you create a table using SQL and by using the existing data from the Delta table. Now let's use this Delta tables for streaming the data. So how actually you will be using this Delta table for streaming the data? Let's see it now. So for that, see, basically before going for this process, I'll tell you few things. This Delta Lake will basically support streaming data, and this delta tables can be a sink or a source for the data streams that is actually created using the Spark structured streaming API, we can say. So in this example, you will use a delta table as a sink for some streaming data in a simulated Internet of Things scenario. Okay, now let me return back to this notebook one. I'm in notebook one now, and I'll add a new code cell below this results. Let me add a new code cell below this results, and let me add a new code here. Basically here I'm just creating a stream data. You can see here like we have this device one status okay and error. This thing is been creating. So here whenever you run this code, you need to ensure that the message source stream created is printed. Okay, so let me run this. I'm just creating one dummy source, that is a stream of data I'm just creating. So this code, whatever you are running right now, this is actually creating a streaming data source based on a folder to which some data has been already saved. This also represents the readings from the hypothetical IoT devices, we can say. Okay, so we have ensured now that source stream created. So this is a successful message we have got. Now in the new code cell, let me add one more code. Okay, okay, now basically I'm just creating a sink now. So here I'm just running this code, so that once you run this code, like this code will actually write the streaming devices data in a delta format, we can say. So let's execute this code right now. So it is streaming to delta sync. Now it is just creating. So this is writing the stream to a delta table. Suppose this, let me add a new code cell to read the data in the delta format into a data frame. Okay, so now let me write this code, and this will read the data in delta format into a data frame. Now let's execute this. So this code will basically read the stream data in delta format into delta frame, and you should note that the code to load streaming data is no different to the used to load the static from the delta folder. Okay, for streaming and for static we are using the same kind of code, we can say. So once you receive this data, let me add a new code cell to create a catalog table based on the streaming sync. So for creating a catalog table, let's write this code here. So I'm creating a catalog table based on the streaming sync, whatever we have received right now. So let me execute this, and this code can be used for the non-streaming data also. The same code, no replacement. Now again, let me add the new code to query the IoT device data table. So let me add the code here. So I'm selecting all the data from the IoT device data. So let me execute this code now. Yes, now you could see that you are actually querying it from the IoT device data table that contains the device data from the streaming sources, we can say. Now let me add one more code cell to add more data to the source stream. Okay, for that let me add a code now. Okay, so this code will add some more data to the source stream. So let me execute this code now. So this is actually writing more hypothetical device data to the streaming source. Okay, now the command is successfully executed. Now let's add one more code section and query the data which is present in the IoT device data. So let me run this code now and query the data which is present in the IoT device data. Now you could see the new data, whatever was added here, is being visible now. Okay, now let me add one more code cell to stop the stream data. Okay, so I'm just using delta stream.stop command to stop the all the streaming data, we can say. Okay, now that you understand how you can use Delta Lake in your Azure Synapse Analytics, now let's go for this quick knowledge check. So which of the following description best fits Delta Lake? Yes, you're right. That is a relational storage layer for Spark that supports tables based on the Parquet files. So you have loaded a Spark data frame with data that you now want to use it in a Delta Lake table. So what format should you use to write the data frame to storage? Yes, you're right. That is a Delta format. So what feature of Delta Lake enables you to retrieve data from previous version of the table? Yes, you're right. That is time travel.